You're live.
Hi, everyone. You're welcome to the third episode of Research Meets Open Source. And today we will be having two very interesting speeches from three different speakers. And before we proceed, I would like to take us on a recap of the previous webinars that we've had. And on our previous episodes, in episode one, we had a research talk on breaking barriers with Eclipse, ThinkWeb, and Nephile. And the second episode was on two different topics, which is on Datamite and also Eclipse Dataspace. And today, we will be talking on the title Unlocking the Power of Eclipse BaSyx with SPADE when Industry 4.0 meets agriculture. So if you want to know more about what we've done in the past, you want to see the previous webinars, you can scan the QR code or follow the link below. And today we will be having, like I mentioned, two different speakers, but the first speaker is Frank Schnicke. Frank is the department head of digital twin at digital twin and engineering at Fraunhofer. So I would like to pass over the screen over to Frank for his presentation. Thank you very much.
Thank
I'll
you very
stop
much for
sharing.
having me. I will just share my screen. Perfect. Okay, so today's topic is on making asset administration shells easy. And now you may wonder, what do I actually mean with that? And what I mean is making the provisioning of asset administration shells easy, but also making the overall interaction with AES easy. In a nutshell, I would like you to enable you to do a very easy implementation. However, before I do the deep dive, I would like to know who of you knows the asset administration shell? Maybe just write in the chat, raise your hand, or give any reaction, please. Perfect. I see there are some people who are not familiar with the asset administration shell. Then I will very gladly give a very brief introduction. Well, the asset administration shell, or AS in short, is a concept coined by the German manufacturing industry that focuses on providing a standardized digital twin. And the idea here is to have really something that is let's say, the common core for all the Industry 4.0 endeavors that are being followed in Germany, in Europe, and hopefully also worldwide. And of course, now you may wonder, what does this mean in detail? And when I say specifying the digital twin for the German manufacturing industry, then you can really think of this as not only being, on the one hand, PowerPoint presentations or specifications, but also very, very detailed technical explanations that go really deep down onto the level of, for example, the HTTP REST interface, the JSON serialization, and so on and so forth, and really provide a, let's say, complete picture of what does it actually mean to provide an asset administration shell on the concept level, on the architecture level, and also on the level of really having a technical implementation. And this is exactly what Eclipse BaSyx is doing, because this specification, as it's nicely written, but it still is no easy read. And what we are doing with Eclipse BaSyx is that we are implementing all the specification, packaging it in a way that you can use it very, very easy. And of course, don't take my word for granted that Eclipse BaSyx is making working with the asset administration shell very easy. Take the word of our users. And for this, I brought two slides that showcase what people can do with Eclipse BaSyx. First, there is Harting. They implemented the digital product path and used the AES and Eclipse BaSyx there as the centralized approach to have a product data management across the entire product lifecycle. And what they implemented there is not only or was not only being shown at the Hanover Fair, but is also available online. And I will, after this talk, share a link with you that you can take a look on this and play around with it on your own. And as I said, they used it for implementing the digital product passport. Just to, again, very briefly put in a nutshell, what is it about? There is on the European level, there's a regulation that products in near future have to provide a digital product passport, so description of what is it, how can it be recycled, and so on and so forth. What is the product carbon footprint and other environment-related information that needs to be stored there. And Harting implemented this digital product passport using the AES and thus passing it along the value chain, having the digital product passport for their products. And their goal is if you now buy something from Harting, you get the digital product passport in combination with the product that you just bought. And the benefits that they saw in using Eclipse BaSyx is, of course, the cost efficiency, because it's open source, it's free to use, and there is no license fee attached. Flexibility and adaptability, again, of course, resulting from the open source way that Eclipse BaSyx is following, in the sense of that they can very easily tailor it to their needs due to the code, obviously, being available open source and appropriate license, and so on and so forth. And also, of course, the independence of providers, again, obviously from the open source approach here, but also from using the asset administration shell as an open standard that can be used without any risk of vendor lock-in. And of course, now you may wonder, well, that's of course very focused on Industry 4.0, but is there something else? Because the following talk is not focused on Industry 4.0. Are there any other domains in addition to what we will be hearing about later that people are using Eclipse BaSyx for, not related to Industry 4.0? And there's another very, very interesting project which has, I would say, very high relevance because it focuses on critical infrastructure. And this is something that we're doing together with NetApp and the University of the Bundeswehr in Munich. And there we're taking a look on not any critical infrastructure, but bridges. And the idea here is to have a digital twin of a bridge, of the entire life cycle of a bridge, for enabling smart monitoring and intelligent maintenance management, in the sense of that all this data is now coming together of a bridge and digital twin, that we can have some kind of health checks on this, increase the safety, and of course extend the lifespan, because we would like to use bridges obviously as long as possible, because if you have to shut them down quickly, that's very expensive from the cost of having to figure out something else, rerouting traffic, and of course in the sense of replacing them. And another very interesting topic there is, of course, that we can help mitigate labor shortages by having an automated monitoring, again based on the asset administration shell and on the tooling. And what they did, and I could name many, many more, but because of the time constraints, I will leave it there. And what they did is they used Eclipse BaSyx for very, very much speeding up the implementation of the appropriate use cases that I just described. And this, of course, leaves you wondering if Eclipse BaSyx can help me with implementing AES or making AES easy, then what is it exactly? And for this, I have prepared a very brief introduction, and if you have any questions about, let's say, specific components, and I shall go deeper, then of course we have the Q&A, or you can also very gladly send me a mail and we can have a discussion afterwards. But first, what are we providing? We're providing the AES infrastructure. That means we are providing, on the one hand, Docker components, for example, or Docker containers, images, that you can use with a very simple Docker compose up and set up your complete infrastructure for the asset administration shell without having to write a single line of code. Everything is very easy configurable, and we are implementing the standard there that is being provided in this AES specification. Additionally, what I think sets us apart from other AES implementations is that we have a very high technology readiness level. We have, and I have to double check this number because I think it's even way higher, but the last time I checked, we had over 500,000 downloads of our Docker images provided on Docker Hub. We are scalable and secure, which means we are not only working in the context of a small prototype or a small demonstration, but we can really go really broad and support millions of asset administration shells. And Eclipse BaSyx is already being applied in mission-critical environments, which means there are companies that are using Eclipse BaSyx for implementing parts that, if they would fail, would really impact their business in the sense of that manufacturing lines would not be working, which I think very much underlines this point of having a very high technology readiness level. And last but not least, we have a very, very strong ecosystem of partners because we as Fraunhofer IESE are one of the maintainers, but of course there are also companies that support you if you want to go into different directions, like having 24/7 support, having service level agreements on regard on availability of solutions that you are setting up or that are tailoring Eclipse BaSyx for you if you do not want to do this on your own. So much for a very high level overview. Taking one step deeper, what actually are the parts of Eclipse BaSyx? We have as I already mentioned, the infrastructure, which are AES Discovery, AES and Submodel Registry, AES Environment, which includes AES repository and submodel repository. If you are not too familiar with that, you can just think of this as the AES Discovery providing a link between asset and an asset administration shell ID, the AES Registry providing a link between the asset administration shell ID and the URL where you can find the data, and the repository as providing this data. And what we're doing there in these infrastructure components is that we are not only implementing the specification, but we are going one step further by providing features that we think are needed for having a real functional enterprise-ready deployment, like interlinking components for quality of life, providing MQTT eventing or Kafka eventing, providing role-based access control, and so on and so on and so on. On the other hand, we are also providing components which are, let's say, not within the scope of the specification, but make working with the AES much easier. This is on the one hand side, upper left right corner, a very nice UI, which I will share on the next slide a screenshot of, and also a component which we call the data bridge, which you can use for integrating data from different kind of data sources like sensors, IoT devices, and so on and so forth with the asset administration shell. These components, as I said, we are all providing as Docker images, but we are also providing software development kits. Because in the end, the Docker images are easy to use, but they do not cover everything, maybe. And if there is a use case on your side where you need no new features, we provide a software development kit that you can use for implementing new features or even change everything about BaSyx at all. On the other hand side, we are providing a client SDK that we are using for, or that we're providing for interacting with the infrastructure. So we are providing both sides. Having the infrastructure exposing HTTP REST endpoints, and on the other side, having the client SDK that enable you to work with this infrastructure without having to worry about the specific implementation details. And the focus of the work that Fraunhofer IESE is doing is Java, but Eclipse BaSyx also covers many more programming languages like C#, Python, and so on and so forth. Well, I already mentioned briefly that we're providing a very, very powerful web UI for interaction with the asset administration shell. And this is exactly what is being shown here on this slide. And you can think of this that you just configure where's your infrastructure running, and then it connects to this and displays everything that you see here. As a very, very brief explanation, on the left-hand side, you see asset administration shells. Asset administration shells consist of submodels, each submodel describing a core aspect and being shown in the middle column, and then the so-called submodel elements, which provide data um, or provide the concrete data, as well as having some specific visualizations on the right-hand side. So as I said, this makes interacting with the infrastructure and with AES very, very easy. However, of course, it kinda requires you to also have some kind of asset administration shell knowledge. And this is exactly where another feature of our AES Web UI comes into play, which we call modules. And what you see here is a screenshot of another demonstration that we shared at the or that was shown at the Hanover Fair. That enables you to use the AES Web UI for implementing user interfaces that abstract from complexity of the asset administration shell and the infrastructure and just focusing really on the user experiences. Which means with the AES Web UI, we are providing an asset that helps on both fronts. It helps you as somebody building asset administration shells, being the AES expert, and it also helps you as providing user interfaces for your users that, of course, may know about the asset administration shell, but in the end just want to have something usable that enables them to very quickly achieve their goals. Another component that I would like to very briefly speak about is the Eclipse BaSyx data bridge, which we are providing again as a Docker image, as a microservice that integrates arbitrary data sources with asset administration shells, like for example MQTT, Kafka, OPC but also industry typical protocols like Modbus, Profinet, and so on and so forth. And the interesting point is that we're using here again, of course, open source software for building this and having it very usable. And I would like to just very briefly showcase this on a very easy example, and that is integrating a heating device, providing data via MQTT with BaSyx, the submodel repository, and then transforming the data along the way. Let's just assume that this heater is sending the payload shown in the left corner, so temperature and a timestamp. And for our scenario, let's assume we don't care for the timestamp and the temperature is given in degree Fahrenheit, but we're only interested in degree Celsius. So that means we need to do some kind of transformation. And this is exactly where the data bridge comes into play. First, we configure where is the data being received, so MQTT broker, topic, and so on and so forth. And then we configure a JSON transformation for which we are using JSONata. And what you see here is, for example, a JSONata expression that just says calculate the temperature key of the JSON, subtract 32, multiply it with 5/9, and floor it. And that's basically the formula besides the floor for converting Fahrenheit to Celsius. And then if we have this, we are just configuring in which submodel endpoint the data should be written into it. And that's everything that you need to configure here at this point for working with the data bridge. And at least in my opinion, what is a very, very interesting point is that the AES Web UI and the data bridge, since they are, of course, we are providing them in context of BaSyx, but they are not specifically tailored to BaSyx in any way, in the sense of that they are using the AES HTTP REST endpoints, and you can deploy them in theory to any other AES infrastructure, may it be proprietary or from another company board, or you build it yourself. That means that Eclipse BaSyx is really, you can think of as a yeah, as a toolbox that is providing you lots of tools that you can just select what fits your interest best. And if you are starting from scratch, we provide the whole package. If you already have some solution for some use cases, you can just pick the building blocks. And if they do not fit exactly to a use case, you can very easy tailor them to your needs. And this is also something that we are packaging here at Fraunhofer IESE and providing in, again, a very easy to use way. Because the open source components itself are easy to use, obviously. But if you want to have them in the deployment that you run for your research projects, for your own, let's say, prototypes that you're doing, we are packaging this in what we call the Asset Administration Shell data space for everybody. And just to very briefly put it in a nutshell, what this is, you can really think about this as a prototyping environment for implementing asset administration shell-based use cases, and even for prototyping use cases that focus on data spaces, which means, for example, that also another Eclipse project comes into play here, the Eclipse data space components, or more precisely, the Eclipse data space connector. And our idea with this is to enable you to very easily use the asset administration shell not only on the level of the open source software that we're providing, but also on the level that we're providing an infrastructure as a service to you that is very easy usable, because from a technical perspective, there we only need to sign a user agreement if you are a member of the Industrial Digital Twin Association, which is the body driving the specifications. You get access to a tenant free of charge. If you would like to use this for other contexts outside of the IDTA, feel free to reach out to me. Last but not least, if you are now wondering on how can I get more involved here, there are two venues, let's call them, that I would like to highlight here. One is called the Eclipse BaSyx Open Hour. I will paste the link of this here in the chat and share it afterwards. It's a monthly meeting where for 1 hour where you are invited to drop by, ask questions and interact with the community. And the other point that we are providing is called the Eclipse BaSyx Developer Alliance, which enables you to not only get involved in the community, but also enables you to, let's say, take, of course, let's say, an influence of what we as Fraunhofer IESE are implementing for ensuring that our work, not only, of course, with Eclipse BaSyx, but in the context of what we are implementing, is aligned with your goals. So, to put it in a nutshell, Eclipse BaSyx is providing lots and lots of cool tools. There are lots and lots of examples that you can use for starting your journey. And if you would like to participate, there is the Open Hour and, of course, the Eclipse BaSyx Developer Alliance that you can use for joining our community. This wraps up what I want to show you. Thank you very much. Are there any questions while I post the links into the chat?
Thank you very much, Frank, for such an enlightening presentation. I believe everybody in the community now knows a little bit more about what Eclipse BaSyx stands for and what you guys have been able to achieve. So now we will be moving on to the second presentation. This one is a joint presentation by the first speaker in this particular session is Aristotelis Tagarakis. And Aristotelis Tagarakis is the senior researcher at Institute for Bioeconomy and Agri-Technology, Center for Research and Technology, HELAS. And today they will be talking about a topic, SPADE, building agricultural drone digital twins with Eclipse BaSyx. Eclipse BaSyx. So, and after Aristoteles gives his presentation, then comes Pablo. Pablo Cunhago Soto is the senior research engineer at the Galician Research and Development Center in Advanced Telecommunications, known for short for as Gradient. So, um, Aristoteles, over to you.
Yes, thank you, Babashile. Um, as Babashile mentioned, I'm Architeles Sagarakis. I'm researcher, senior researcher at CERT, and we are coordinating the SPADE project, which is actually all about drones in agriculture and forestry, with the title, the big title of a multi-purpose physical cyber agri-forest drones ecosystem for governance and environmental observation. So I will just provide you a short, very short introduction to our project, and of course, then Pablo will move on with more technical details about our digital twin development. So a few words about the rationale behind Spade. So why did we develop Spade? Why did we think of this project? First of all, the use of drones is increasingly applied for agricultural purposes. So, however, there are many risks that are related to drone operations that still need to be addressed. Furthermore, the regulations concerning the use of drones in agriculture and forestry are quite new, and new applications and services are being emerged all the time, and the technological architecture is quite complex. Um, Therefore, with SPADE, we aim to develop an intelligent ecosystem in order to address the multiple purposes concept of deploying UAVs, drones in agriculture and forestry. So, our goal is to promote sustainable digital services for these two sectors. Forestry, crop production, and livestock. We also have livestock part of agriculture systems. Now, a brief introduction to our consortium. It's consisting of 21 partners from 9 European countries and the United Kingdom. The consortium is multidisciplinary from universities, research institutes, SMEs, and consulting companies. We also have two cooperatives. So uh, it's quite effective consortium covering all the aspects. Um, So the specific objectives of our project. Our first objective was to learn ourselves and engage others in learning about drones and how we can use them, having a multidisciplinary consortium, and to achieve this multi-purposeness of these vehicles in agriculture and forestry. The second objective is to develop cost-effective drones um, for agriculture and forestry for the sectors that we are addressing. The third objective was to develop an open source ecosystem. I will explain more in the next slide. And finally, to test all the developments for drones in deploying three different pilots. And of course, to make the innovation known and used broadly by anyone in these sectors. About Spade now, in a nutshell, how we have organized Spade. We have work package one. We have the governance aspect, where we are mapping the innovation requirements, all the regulations, the recommendations. We perform socioeconomic and environmental evaluation of using drones in agriculture and forestry. We are also in this governance package. We are addressing the gender aspects, cybersecurity, standardization activities, and many more. Or also, we have the physical system, on the other hand, where we are developing the spade drones, different types of drones, different sizes, different utilizations um, uh, and specifications. So whatever is needed actually to feed our pilots and test them in our pilots. Uh, so then we have the cyber system where we have actually the development of the Spade ecosystem with the Spade platform and the digital twin. And finally, the pilot cases where we are testing all the developments. Um, Now, about the pilots, as I mentioned, we have three pilots, starting with forestry, where this one is launched in Norway, and it's all about forest inventory, forest harvest, and other forest operations using drones. Uh, our second pilot is in crop production. This one is launched in Spain, in the Balearic Islands. So it is focused on different types of crops, like potato crops, arable crops, potato crops, and fruit farming, different trees in terrace crops. For that one, we are focusing on scouting, disease detection, crop monitoring, and many other operations. And finally, we have the livestock pilot, which is launched on a Greek island in Lesbos, where we have different use cases aiming to promote and improve breeding via grazing and health monitoring of sheep flocks. All this within these three pilots, we have different use cases where we are testing different types of drones in terms of size and operation. So we are developing and testing small drones, forming a swarm, and to be utilized in the different pilots. We have the second case where we have the two different medium-sized drones cooperating with each other, and the final is the large drones for different operations and applications in the three sectors. Uh, Now, also we are also addressing policy aspects. So within SPADE, we are mapping the policies that are related to drones and are used in agriculture and forestry. So far, we have grouped all these policies in four different groups, four different categories: operational, environmental, and ethical, data and technical. Um, and finally, as I already mentioned, SPADE is contributing to several standards. So we're very active in standardization activities. There are several standards that we have already
I
contributed to, like digital twin reference architecture, security and privacy of digital twins, and system of systems with UAS reference architecture. And we keep on working on these standardization activities. And finally, now we move to the core developments for the SPADE ecosystem. So the part of the SPADE ecosystem is the SPADE platform, where we have the different tools, services, datasets, and repositories shared from using this SPADE ecosystem, and of course the digital twin. So SPADE. So the idea is that the users are connected to the platform through different providers, service providers, or farm management information systems, or any other providers, and then we have all the components of SPADE connected to the platform as well. So this is how the connection is being done among to exchange the different data sets and the different services within the ecosystem. So Gradient is the relevant partner developing the SPADE platform. So within SPADE platform, as I mentioned, we are developing the digital twin infrastructure to facilitate users in developing digital twins for drones and other applications. Now, SPADE is focusing on forestry and livestock and crop production mainly, but of course, these digital twins can be expanded to different applications as well. And with that, I'm closing my presentation. So as I mentioned, it's a brief introductory presentation. I will give the floor to my colleague Pablo from Gradient, who will provide more details about the digital twin and where, of course, we are using BaSyx for its development. So, Pablo, the floor is yours.
Thank you, Aristotelis. I'm gonna share my presentation.
Okay, so first of all, thank you, Aristoteles, and thank you, Babashile, for the presentation and for having us here today. I'm gonna give a brief presentation of myself. I'm Pablo Couñago. I'm a telecommunication engineer by the University of Vigo. I worked there for a few years, researching and working in the fields of mobile communications and mainly embedded systems. I've worked in many projects there, and in 2016, I joined Gradient as a research engineer, and there I moved a bit from to the fields of IoT networks, also embedded systems, and in the last years, mainly Industry 4.0 technologies. To give a brief explanation of what Gradient is and what we do, Gradient was founded in 2008 as a private foundation, and its main goal is to get to the digitalization of companies in the region of Galicia, in the northwestern region of Spain. Through the years, we have been growing to our current 250 plus staff of researchers and engineers. And we have also collaborated in many projects, including 18 European projects we have active as of now. SPADE, by the way, is one of these European projects we have active today. We have also collaborated with more than 400 customers, mainly small and medium enterprises in Spain, but also international companies and so on. Regarding the goal of Gradient and what its reason of existence, an ICT like Gradient's main objective is to take technologies from lower TRL levels, mainly working with universities in basic research. Take those technologies, advance them a bit, develop them, and transfer the results and the acquired knowledge to the companies in the area to help them advance in their as I said, their digitalization processes and make the IT industry more advanced in our surrounding. To reach this goal, Gradient works in three main sectors or three main pillars, which are connectivity. We can explain this as every measure to take information from one place to the other. We can gather information from a sensor, transmit it through a wire, through fiber optic, through wireless communications to a separate place where we can do something with this information. The intelligence part of these activities, of these technologies, is what we do with this information, how we manage it, how we store it, how we analyze it, how we extract value for this information, how we get insights from this information in order to make the right decisions based on this information. And also the security part is wrap around all of this work we do. We have to put security as we advance in the integration of different systems. The protection of data and information systems is more important as we get to this process. Now, talking about SPADE and what we do in this project, we were given the task of creating a digital twin platform that can work for different use cases. In this project, as Aris told us, we have three main sectors. We have forestry one, a livestock, and an open field. So we have to create a platform that can model all the information generated by these use cases. We come from, as I said, I come from the industry sector. I have knowledge about the Industry 4.0 technologies. So can we apply what we know from the manufacturing processes and the Industry 4.0 to these use cases? And our idea, our answer to this question is positive. We think we can use the IESE specification outside of a factory, in this case, to agriculture sector. The IESE specification has many features, but some of the key features are the use of standardized data structures through models and submodels, where we can structure information in a known way, so it can be shared among actors without them knowing, having previous knowledge about what they are getting. They only need to know what type of data they are getting, and they have all the metadata necessary to interpret it. The IES specification also provides standardized interfaces, which is great for interoperability. You develop an interface, and it's ready for everyone to use without previous knowledge, because it complies with the standard, and everyone knows how it works and what to expect as a response. And the reusability is also a great feature of the IES standards, as you get some pre-made models and submodels that you can use in different sectors apart from the manufacturing sector. Apart from that, the base of the Industry 4.0 is the digitalization of processes, but processes are also used outside the manufacturing industry. Other sectors like healthcare, agriculture, energy, or transport can also be modeled in the same way, and the tools already available for Industry 4.0 can be adapted or even directly used in other sectors apart from the manufacturing one. So, as I said, our answer to this question is we can use these technologies outside of the manufacturing sector. So, as I said, we were given the task of creating a platform to model and to gather information from different use cases. Like I said, the forestry one, the livestock one, and the open field one. All of them have in common one thing, is that they all use drones in their use cases for different tasks, but they all use drones. So in order to solve this task, we relied on BaSyx. BaSyx provides us a set of tools that we can use to easily create digital twins. We have a set of services that allow us to deploy already made models for different tasks. Like, for example, we already have some models for a digital nameplate, or integrating documentation in the digital twin, for integrating time series data in operational data, for integrating whatever thing you can imagine in an industry, in a manufacturing process, is already there. So some of these models can already be used outside of this sector. We also have, as has been explained previously, the IESE data bridge. This service is quite useful, as it provides already an integration with many protocols, mainly industrial protocols, but it can be adapted for other ones. It's quite easy to develop new interfaces for this service and integrate new protocols. We are using right now an integration with a REST API, but it could be expanded for other use cases, for a database or whatever protocol you may need in your use case can be integrated. So this platform already gives us a lot of tools, and already gives us a lot of work already done, that we don't need to work from zero on that. To simplify the deployment of these digital twins, we are using a Kubernetes cluster, where we can easily manage the deployment of the services through APIs. I'm going to explain that a bit more later. And we have two more services. One is the deployment API that we use to manage this deployment of instances through the Kubernetes cluster. And the other one is the digital twin API, that is how we manage the creation, the flexible and the customizable creation of digital twins from templates that we have defined for this project. So the first step that we have to do in order to create this digital twin platform is to understand what the physical assets we want to model are, and what information they provide, and what we have to do to get this information in a standardized way and put it in a model that we can use. So as I said, in SPADE we have 3 different use cases, and all of them use drones. So our first approach to this to the solution is to model drones and use them as a template, so we can easily starting from this template, customize it and adapt it to each separate use case. So in this first step, we include the use of drones to gather data from all the use cases, all the fields, and we created a flexible a flexible platform that we can later expand with the addition of new templates for other assets, like I don't know, payloads that we can include in the drones, or other assets we may have in the use cases in our fields. We can have maybe some other hardware that provides information that we can integrate to a separate protocol or whatever, and we can model it, and we can include a new template, and we can use that to deploy an instance in our platform with these tools. It can be also expanded with new data structures and with new data sources. As I already said, we are using the BaSyx data bridge that provides a lot of readily available interfaces for different protocols, and it can be expanded with new ones if needed. So in order to create these templates, we identified what information a real drone provides us. We extracted some information from DJI branded drones. We gathered some data. We identified variables and properties we can have, and we created some basic models with as a template. We created these templates using the IESE Package Explorer application. We saved these templates as IESX files that we can then reuse in our platform to create different digital twin instances by modifying, customizing this template and adapting it to each separate use case. Well, regarding the digital twin templates, we have this service that does mainly two tasks. One of them is to manage the templates, and the other is to manage the digital twin instance. The SPADE platform is mainly focused in the reusability feature of the IESE standard. It uses the IESX files as templates, which can be customized, as I said, to create digital twins adapted to each use case. The platform takes these templates, analyzes the provided properties, and removes all the properties that are not needed. Sorry, excuse me. It removes all the properties that are not needed in the specific use case, and this way it adapts the digital twin to the specific use case we are working on. So the platform is designed to manage a catalog of templates through this REST API using CRUD operations. So we can create new templates, we can delete existing templates, we can update a template uploading a new IESX file, or whatever other operation we may need to manage these templates. We also have this other concept of digital twin, and this feature, which is the digital twin manager. From these templates, we create digital twins, as I said, adapting the template to the use case specific for this use case. So we have a min IO object storage we use for storing both the templates and the modified IESX files we create from the templates. The flow of information would be a user wants to create a new digital twin, so it selects he selects a template to start from. The template is modified and adapted to the specific use case. The modified IESX file is uploaded again to MinIO in a specific location for owned by this user, and it's then used to create the instance of the digital twin in the Kubernetes cluster that I'm gonna explain later. I'm not talking here about how we integrate information from from the outside world, from the real world, from the real assets, because that's developed by another partner in the project. The partner is called Vavenir, and they developed a platform, a tool, which is called Data Broker. It's a project that's already open sourced in the SPADE project, and this platform exposes a REST API where we can get information from every pilot as a standard REST API with metadata for each property, for each variable. So that's our main data input for the digital twin, but we could integrate other data sources if needed through whatever databases or other protocols we may need to integrate in the future. It's available for us as we are using BaSyx, and it's quite easy. So as I already explained, the digital twin manager, we have now the deployment API. This is the last part of our development. Is the tool we use to create a real digital twin, to deploy it to the infrastructure and have it available for us to fill with real data and to watch the data, to review the data in the web interface. So we have a Kubernetes cluster. As a user wants to create a new digital twin instance, it gathers the information stored in MinIO. It creates the configuration files for the different basic services for the data bridge to map the variables from the input sources to the specific IESE properties that we created in the template, in the model. It also creates all the configuration files for different services regarding subdomains or whatever information is needed to deploy the services in a Kubernetes namespace, separated from the others for security reasons, as we are using as we are having many users in our platform and many companies, many separate organizations that may not want to share information from their specific use cases. And this process is quite automated right now. When a user commands the creation of a new digital twin instance, the system gathers the service images from our Docker repository. It uses Helm to deploy the services to the Kubernetes cluster. So everything is quite automated right now. We can customize it quite a lot. So we can decide where to deploy it and when to deploy it and how to deploy it as our needs may change. And I think that's it from my part. I'm ready to answer any questions you may have.
Yes, there is a question here, but I'm also going to pull in Frank because we did have a question that came in earlier, a few of them actually. And I just want to make sure that everybody had an opportunity to address them. Frank, I did see you quite active there, but one that came in earlier from Marco was, and I'll bring it up on the screen. You mentioned the relation to data spaces, which is very nice. Is there also a relation to the Gaia X initiative?
Yeah, I think I already answered that in the chat, but I will very gladly do so again here. We are in contact with, for example, Container X and all these Manufacturing X projects, which are kinda, you can think of, I would say, to put it in a nutshell, coming or using the concepts of Gaia X. So yeah, we are in contact there.
Okay, perfect. And now there is another question here, which says, excellent. I am more interested in the second case where not all DTs in the CPS is not adhering to the AAS standards. Does this ensure the bidirectional loop, so we can call them DTs? I mean, not only interactions between physical twin to their DT, but also DTs to DTs. There's a lot of abbreviations here.
Yeah. So what the data bridge can enable you, and I didn't mention this during my presentation, but I wrote it in the chat. It cannot only pull data from a data source, but also push data there, which means you can have a feedback loop with other, let's call them data sources or data providers, data consumers, that in the end may again be digital twin, which means you can have a loop with the AES and another digital twin, not following the AES standard. And even, again, a very nice feature, the data bridge also enables you to take data from an AES, convert it, and write it to an AES. Which means if you have a use case that is not having, let's say, some very complicated business logic, but instead is following this ETL pipeline approach of just transforming data, then in theory you can have something like, just to paint an example, you have an AAS that provides information about what is a sensor that is providing a voltage. You have another sensor that is providing ampere. And then you can have a third asset administration shell for some for some context, for example, for the big product having the two sensors that just takes these two data points, multiplies them, and then provides the watt that the device is consuming, so to say. And this is something that you can already deploy using Eclipse BaSyx data bridge without having to write any custom code.
Okay, great. Well, this is the last opportunity. Anybody in the audience have any questions? In the interim, thank you all so much for excellent presentation today, and the engagement in the chat was wonderful as well. It doesn't look like there is any other questions. So just a quick heads up that we will be posting a survey. We would really enjoy everyone's feedback. I will put it in the chat, the link in the chat. And lastly, this webinar will be available after this session directly here in Crowdcast, and as well on our YouTube channel. Thank you all very much again, and have yourselves a wonderful day. Thank you.
Thank you, everyone.
Bye.
Thank you.